Hi everyone, it's Miss Engler. These are your notes for 8.4. What is wind and how do we measure it? So, for you to do now, you're going to describe the wind. So, how are you going to define the wind? We talked about it a little bit the other day in class, how maybe you don't necessarily feel air when you're just walking through. You don't necessarily feel, and it's very hard to say that you could feel the atmosphere around you, but we do feel wind. So, how would you describe that in your own words? When you're done with your do now, you're going to go on to the next slide. On this slide, you're going to answer, what do you think drives the wind? So that will be your response that you put in here for yourself. On the following slide, this talks about what wind actually is. So wind, or advection, is the horizontal movement of air. So you guys will write that in there, the horizontal movement of air. I believe it's just horizontal for you guys. So wind, like we said, is the horizontal movement of air. And wind is just described in terms of its direction and its speed. So its magnitude. So the way that we actually get wind is caused by differences in air pressure. So as you can see on this diagram, the wind, if you look at the arrows, is blowing from the ocean to the land. So you notice the H means high, so that H is going to mean high pressure. And the L means low pressure. So this high air pressure is pushing down on the cool ocean air. And as it moves closer to land, it actually starts to warm up. The longer it's been in the water and the more sunlight that's beating on it, it starts to warm up as it reaches the land. And then land is warm. So that sand has been cooking in the sun all day, is nice and warm. And so the air is going to heat up. And because the air is heating up, it becomes less dense and it's actually going to rise, creating a low pressure system. And that is how our air is going to move. And the reason that it actually does move, that air doesn't just get pushed down and down and down, is because this low air is actually rising. And because it is actually rising, it's creating open space. It creates free real estate. It's free real estate. So it makes a little opening so that high air pressure system, that air can flow into the lower concentrated area of air molecules. And that is how we get wind, is actually air moving from areas of high concentration, high pressure, to areas of low concentration. So on this slide, this is actually slide 7 if you guys are counting. It says here at the bottom, slide 7. So we have two types of air pressure systems. We have low pressure systems and we have high air pressure systems. So low air pressure systems, I've talked about this a few times, that low pressure systems are gross. So low pressure systems have warmer temperatures. I say gross because I always think of like New York City summers. If you look outside during the summer and it is overcast, if you can't see the sky, if the sky just looks like gray, you know if you step outside, it is gonna be muggy. It is gonna be disgusting. So you're gonna step outside and you're gonna start sweating and you're never gonna stop. And that's a low pressure system in New York City. In in any low pressure system in the northern hemisphere. So we gotta remember this is for the northern hemisphere. The winds are going to move counterclockwise. So in this diagram, you can see that the air is actually circling counterclockwise. And the reason it circles like this is because of the Coriolis effect, which we will discuss in a few days' time. A high air pressure system has colder temperatures or cooler temperatures, and our winds rotate clockwise. So you can see they actually rotate the opposite direction. These are kind of difficult diagrams for some people to draw. It's just, You just gotta flip your brain a little bit. So, yes, I think that's all I got for that slide for you all. So the way we measure wind direction is using something called a wind vane, or sometimes it's called a weather vane. But they were made originally with they usually have animals on them. My mom, growing up, had one with a cow because she was obsessed with cows. So, animals, when they're in the fields, wandering around, I can say this because I grew up in Colorado and I know what animals do in the field. If you see a bunch of animals standing in a field and it's a windy day, they stick their butts away from the direction of the wind. So the wind is coming from this direction. They don't want wind blowing in their face, so they stick their butt towards the wind. So the tail is going to show you where the wind is coming from, and their head is going to point where it's going. So this is from, and this is going. So winds are named for the direction from which they come. So a northern wind, northern wind, I'm just going to abbreviate the W. A northern wind comes from the north. So a northern wind, if you were to draw that, let me just underline that in blue. If you were to draw a northern wind, you'd actually see an arrow like this. Northern wind comes from the north. If you look at the diagram we have here, this wind, the butt is in this direction, so that'd be like the tail feathers is in that direction, is actually coming from the southwest. We usually say north and south first before saying east or west. So those winds are actually, this is a southwesterly wind. And I'm trying to change the slide, sorry. Okay, so wind direction is determined by air pressure. Those are your two words that you're going to write in there. So, like I talked about a little bit on the other slide, wind blows from areas of high pressure to areas of low pressure. So if you have a high pressure system, so yesterday, on Thursday, it was a very high pressure system over New York City. So it was very bright outside. It was very sunny. It was very dry and it was cool, but it was like warm. But it wasn't like a few days ago when it was like really muggy and gross and warm at the same time. So that air that's in a high pressure system is going to push down and it's going to flow into low pressure system areas. So high pressure systems, remember, have colder temperatures. That's something you guys need to remember. They have cold temperatures and they move clockwise, whereas low pressure systems have hotter or warmer temperatures and they move counterclockwise. So I lied. We're actually talking about the Coriolis effect today. I just forgot about the slides. So a Coriolis effect is this effect that happens when an object traveling in a straight line across Earth's surface is deflected to the side. And this is actually caused by Earth's rotation. So if there's some sort of object, let's say that there is I'm going to draw a terrible plane. That's my plane. That's the worst. Okay. I'll cry myself to sleep later. Okay, that's my plane. My plane is trying to fly straight up to the North Pole. But what appears to happen is that because the Earth is rotating underneath the plane, it's going to appear like the plane is actually moving off to the right. So it appears that it is deflected to the right, the northern hemisphere. But if that plane is trying to go south, it actually appears to be deflected left in the southern hemisphere. Pretty cool stuff. It's a little hard to conceptualize, so don't worry about that. We will also be posting a Edpuzzle eventually for that. So if you watch this video, I don't think it works on your devices, so I will post this for you guys on the classroom. These guys are going to throw a ball back and forth, and it actually demonstrates the Coriolis effect. So wind speed is going to be determined by the air pressure gradient. So the larger the gradient, or the greater the difference there is in between places, the stronger the wind is going to be. So if you look at this, these ISO lines are far away. So that means it has a pretty shallow gradient. So if this were a hill, this would be a nice gentle hill you take 2-year-olds on sledding for the first time. The steep gradient is like the black diamond in like snowboarding and skiing. Like that's like you have to be really, really advanced because it's super steep. We're going to have very weak winds over here, and we're going to have strong winds over here. So if you look at that diagram, weak winds over there, strong winds over there. So on these ISO maps, I did just note this now. If the isobars are far apart, they're going to have a gradual or low gradient, low wind speed. If these isobars are really close together, they're going to have a steep pressure gradient and high wind speed. Just a reminder to you guys, this is coming back, that cold temperatures are high pressure, warm temperatures are low pressure. High pressure systems move clockwise, low pressure systems move counterclockwise. So if you look on this diagram, what you can see is that in this area, I want you to draw a little arrow for us. We're going to go from our high pressure system to our low pressure system. And then down here, we have high pressure that's a larger number on our isobar, and it's going to move, sorry, I wasn't highlighting it. So this one is going to move up towards a lower number on that isobar. So make sure you guys draw on those lines. And then you guys just have 2 practice questions, actually 3, 2 on this and 1 on the next. Earth's surface winds generally blow from regions of. And then in the northern hemisphere, planetary winds are deflected to the right due to the what? Then on your last slide, second to last slide, which map represents the surface wind pattern around a northern hemisphere high pressure center? And then to the right, which map represents the surface wind pattern around a northern hemisphere low pressure center? This actually, I think that this might be too small to see, so go ahead and skip this one. I'm sorry, that picture is too small. I didn't look at it until now. Whoops. Then the last one, what causes many surface winds to deflect to the right in the northern hemisphere? Wonder what that question's going to pop up on. Alrighty, y'all. Good luck. Feel free to reach out to me if you have any questions, and we'll see you in class. Bye, guys.